On July 1st, 2025, astronomers detected something extraordinary racing toward our sun at a speed of 58 kilometers per second. The object wasn't native to our solar system. It was given the name 3I Atlas. And soon after, Michio Kaku issued a stark warning. He suggested this was not a typical alien comet, but perhaps a visitor of godlike proportions, larger and stranger than any object we've ever encountered. Official readings confirmed that its size matched the greatest comets ever recorded, and its brilliance was unmatched. Yet behind the public disclosures, evidence was emerging that hinted at something beyond natural explanation. The real question was, what exactly did Kaku observe that compelled him to step outside the usual caution of scientific ranks? And what would happen if humanity was unprepared for what was on its way? At precisely 4:13 a.m. on July 1st, the Atlas Observatory team in Chile registered data that stunned the community. A faint streak appeared in the star-heavy backdrop near the galactic center, a region so full of light that objects are often invisible, yet this one glowed distinctly. Within minutes, tracking software locked onto its motion, 58 kilometers per second. Inbound, that figure was nearly double the fastest asteroid ever observed in that part of space. When researcher Larry Dino examined the trajectory, he realized this wasn't a simple fast rock. Its course didn't curve back toward the sun in the usual cometary fashion. Instead, its calculated path placed it outside the influence of the sun entirely. With an eccentricity above 6, it exceeded all boundaries of a gravitationally bound object. The orbital solution was irrefutable. This was an interstellar wanderer. The alert spread across global networks. Observatories in Hawaii, South Africa, and Spain swiftly redirected telescopes. Within hours, the Minor Planet Center confirmed its classification and issued the formal label 3/Atlas, marking it as only the third recognized interstellar body in history. The last time such an object appeared, scientists were still debating their very existence. Now there was no question. Its trajectory sliced through the solar system's plane at a steep retrograde angle, contradicting the flow of planetary orbits. Its projected path traced from the deep heart of the Milky Way's thick disk, suggesting origins older than our sun itself. As confirmation spread worldwide, Michio Kaku issued a foreboding statement, labeling the object a cosmic wildcard, a visitor bearing knowledge from before our solar birth. His remarks challenged common assumptions. What if this wasn't an icy interloper, but something different? Something capable of altering humanity's understanding of cosmic phenomena? Urgency mounted as each new bit of data reinforced the strangeness. Speed, direction, and improbability all narrowed into a single unsettling thought. Was this an ordinary astronomical visitor, or something beyond comprehension? The Atlas Network organized a full-scale observational effort. Within a day, over a dozen major telescopes tracked it. Photometric analyses revealed it was brighter than expected, demanding immediate attention. Across multiple continents, amateur sky watchers contributed their own measurements, feeding into the shared effort. The atmosphere wasn't one of panic, but of electric tension, a recognition that nature had dealt humanity a puzzle beyond any preparation. What was undeniable was that 3I/Atlas was closing in on the inner system. It was a once-in-history event, following a one-way trajectory, and scientists had only a short window to decode it before it slipped beyond reach forever. This object wasn't a common interstellar traveler. Its haunting presence dwarfed nearly everything recorded so far. Surrounding it was a glowing coma of gas and dust that spanned some 700,000 kilometers, almost twice the distance between Earth and the Moon itself. Envision a sphere so immense that Earth's entire orbit could vanish inside it, cloaked in haze. By comparison, even the most dramatic comets fall short of this colossal scale. However, the greatest enigma was buried within the haze. The nucleus, the central solid body, was vastly disproportionate to the mighty halo. Current estimates placed it between 0.3 and 5.6 kilometers in diameter, the size of a city or a mountain hidden inside a veil that could engulf entire worlds. The sheer contrast made the discovery feel unreal. An ancient, compact core trailing a vast veil that eclipses nearly anything else in the inner solar system. This isn't just a question of size. From the first observation, the comet's radiance has exceeded all projections. Telescopes in Chile and Hawaii captured a glow far stronger than what a distant comet should generate. When the James Webb Space Telescope pointed its infrared sensors at 3I Atlas, it confirmed what ground-based teams had already begun to suspect. The coma wasn't only massive, it was unusually dense, hyperactive, and rich in carbon dioxide. That activity drove a steady gale of dust, creating a shroud so thick it masked the nucleus entirely. For perspective, if laid next to the Sun, the coma would envelop more than half its diameter, while the comet's solid heart would barely be visible as a speck. This object exists at extremes, a spectral titan cloaking a small, ancient core. The real question gnawing at astronomers since the first sighting is, what process could forge such a vast atmospheric shell around such a modest nucleus? And what secrets are fossilized within that city-sized fragment of ice and rock that has drifted across interstellar space for eons? The haze around it keeps the answers hidden, deepening the mystery. Each fresh reading only multiplies the questions. This isn't just a large comet, it's something pushing the boundaries of what we thought possible. Astronomers have tracked thousands of comets, but nothing like this. Its bizarre combination of velocity, trajectory, and scale has no match in the record books. Its retrograde path, cutting across the ecliptic at a near-perfect angle, defies probabilities, like a coin infinitely balanced on its edge. Before even considering composition, the trajectory alone was unnerving, but the chemistry raised even more unsettling doubts. Readings revealed activity levels far beyond reason for an object so remote from the Sun. Its brilliance defied the models. The torrent of dust and vapor escaping the nucleus didn't behave according to known laws. The leading observatories on Earth were pressed into service. Yet with each new discovery came complications, not clarity. All eyes turned to the James Webb Space Telescope to cut through the obscuring glow and detect traces of exotic molecules, signatures that might reveal the birthplace or history of 3I Atlas. The scientific community braced for revelations that might upend cherished assumptions about comets and interstellar wanderers. Unease accompanied the anticipation, because if the data continued to reject conventional rules, then everything thought to be understood about such visitors had to be reassessed. What, then, is 3I/Atlas? A freak specimen sculpted by chance? Or does it represent phenomena beyond our natural categories? The James Webb's first chemical breakdown provided the biggest shock yet. Its sensors peeled back the coma's glare and recorded ratios that stunned the research team. Carbon dioxide levels overwhelmingly dominated the composition. The ratio of carbon dioxide to water stood at 8:1, so extreme it fell outside any precedent. Only one comet in memory, C/2016 R2, came remotely close, and still not to this scale. Typically, comets within our system show far more water than carbon dioxide, often exceeding by tenfold. But here, carbon dioxide dwarfed water. Numbers showed the comet shedding roughly 129 kilograms of carbon dioxide every second, with water trailing at just 16 kilograms. The disparity was sharp, unambiguous, and unlike anything previously recorded. Infrared analysis split the coma's light into bands, confirming carbon dioxide signatures at every wavelength, drowning out the usual water markers. Additional traces of carbon monoxide and carbonyl sulfide were detected, though small compared to the staggering carbon dioxide surge. Statistically, this placed 3I Atlas far outside established ranges, 6 standard deviations above norms. This wasn't a comet made to solar system specifications. Further context made the anomaly even harder to dismiss. At the time of measurement, 3I Atlas was still 3.3 astronomical units from the Sun, beyond the orbit of Mars, a region where most comets are only beginning to warm and awaken. Yet here it was, already blasting with carbon dioxide in volumes unseen. The production levels pointed to 2 possibilities: formation in an environment loaded with carbon dioxide ices, or a prolonged journey through cosmic radiation fields that stripped away water, leaving carbon dioxide dominant. Neither option matched solar system standards. The Webb team compared known comets, but the 8:1 ratio stood alone, with no true precedent. Even the anomalous C/2016 R2 couldn't replicate the scale or consistency displayed here. Within interstellar chemistry, that raised a glaring red flag. It suggested either birth under unusual conditions rich in carbon dioxide, or billions of years of radiation altering its elemental mix, both scenarios alien to local comet populations. These results had further implications, with carbon dioxide ruling its composition. The ejected dust and vapor behaved under a different set of physics, sublimating at different rates. With altered particle sizes and electromagnetic reactions, Webb's early findings prepared the scene for the next twist: nickel vapor present in the coma. Yet the typical iron signature was absent. But even without that enigma, the carbon dioxide numbers alone pushed astronomers to reconsider everything thought possible about comets entering from deep space. If the chemistry defies explanation, then its birthplace must be even more unusual. Current evidence suggests 3I Atlas emerged from a region where the rules diverge from anything familiar, where carbon dioxide plays the central role rather than being a trace component. That alone means the object has already begun redrawing the limits of what researchers believe comets could be. The first shock came from the ultraviolet spectra. Clear nickel vapor lines appeared earlier than expected. Using the UVS spectrograph at the VLT in Chile, scientists measured 22 distinct emission lines tied to neutral nickel. What startled observers even more was the complete lack of iron. Normally, solar system comets release nickel and iron together in well-defined ratios that scarcely change even after eons of dormancy. With 3I Atlas, the balance collapsed. Nickel appeared everywhere, but iron was nowhere to be found. The lines were unmistakable, precise, and repeated exposure after exposure, removing any chance of measurement error. The likely source molecule was nickel tetracarbonyl, NiCO4, which only forms in environments saturated with carbon monoxide and nickel, and which falls apart in sunlight almost instantly. As the coma spread outward, this fragile compound disintegrated, freeing nickel atoms to scatter ultraviolet light. The missing iron suggested either a nursery that favored nickel or a mechanism that trapped iron in minerals resilient enough to resist vaporization even at these stellar distances. In July and August, the VLT campaign tracked the nickel output as 3I Atlas moved inward, from $3.90 to $2.80. The rates rose sharply, scaling with distance to the -8th power, a sensitivity far steeper than normal comets. That gradient strengthened the case for volatile, unstable parent molecules like nickel carbonyls. Meanwhile, James Webb's readings of carbon monoxide, backed by terrestrial observations, completed the chemical puzzle. Together, they indicated a nickel-rich, oxygen-poor nucleus with just enough free nickel to drive this odd chemistry. No iron appeared, even at the detection threshold of the VLT's best measurements. This broke one of the most consistent rules of cometary chemistry in our system. Nickel to iron ratios sit at a stable level much higher than cosmic averages, but still show both elements in tandem. With 3I Atlas, the ratio was effectively infinite. That wasn't an error, it was a clear chemical signature. Whatever environment shaped this comet either concentrated nickel disproportionately or buried iron so deeply that not even solar heating across billions of kilometers could unlock it. The idea of nickel carbonyl as the parent molecule argued for a cold, carbon-heavy disk where nickel bound to carbon monoxide before being frozen into ice. That sort of chemistry doesn't occur in today's solar system. For the observers, this nickel anomaly wasn't just curious, it was diagnostic. It marked the object as the product of a distant and alien forge. The presence or absence of certain metals can alter a comet's response to sunlight, its dust-charging behavior, even the subtle forces that tweak its orbital path. As 3I Atlas progresses inward, these metallic interactions may quietly shape its movement, leaving faint but measurable traces, with carbon dioxide dominance, carbonyl compounds, and now nickel without iron. The case for an extraterrestrial recipe, unlike any cometary model, grows more convincing. Then came an orbital revelation that startled analysts. 3I Atlas isn't only traveling at an unusual angle, it is practically aligned with the planet's flat orbital disk. Its inclination measured at 175 degrees retrograde, meaning it moves almost perfectly opposite the planets, but just 5 degrees off the ecliptic plane. For an interstellar object, that is akin to threading a needle across light years. The probability? Only 2 in 1,000. Typically, interstellar bodies barrel through at steep random inclinations, rarely grazing the Sun's thin planetary system. Yet this one ran nearly flush with the disk, but inverted. That slender 5 degrees offset put its path almost exactly across the zones occupied by Venus, Mars, and Jupiter, creating a trajectory that functions like a survey line across the solar system. Imagine the system as a record spinning, and this body skimming just above the grooves, but in reverse. That alignment was more than quirky geometry. It turned the comet's passage into potential gravitational encounters with multiple planets, an outcome rarely seen. Statistical models highlighted just how implausible such a configuration is. Out of millions of approach scenarios, only a slim fraction yield alignments within 5 degrees of ecliptic, and even fewer arrive traveling in retrograde. The chance? About 0.2%. Lower than tossing a coin and landing heads 8 times in sequence. Even the Oort cloud's inbound comets don't match such precision, and interstellar visitors are expected to be less predictable still. Yet, this one tracks almost exactly with the solar disk, only reversed. That alignment forced repeated rechecks of the data. Analysts recognized it wasn't just improbable, it bordered on unique. Such a trajectory meant the comet wasn't soaring through empty lanes. It moved squarely along the planet's highways, raising questions no one anticipated. The next phase became clear: simulate close encounters planet by planet and test whether the odds of such precision get even stranger. 3I Atlas isn't simply cutting across the inner solar system at random. Its trajectory passes strikingly close to 3 major planets: Venus, Mars, and Jupiter, in a sequence that feels anything but coincidental. The closest approach to Venus comes at about 65 cents, followed by an unusually near pass to Mars at just 19 cents, and then a sweep past Jupiter at 36 cents. To put that in perspective, 19 cents, less than 30 million kilometers, is closer than the distance of many main belt asteroids to Mars. Each approach occurs within a tightly clustered time frame, as though the object is tracing a reconnaissance route across the system's heart. When orbital experts ran their simulations, the results were staggering. Interstellar objects generally streak through the system at steep inclinations, avoiding planetary planes entirely. The chance of even one close planetary flyby is rare. The odds of 3 sequential flybys? Below 0.005%. That kind of alignment demanded more than one recheck of the math. Mission planners couldn't help but note that the flybys almost mirrored a planned sequence. Venus could bend the trajectory slightly, lining up an even tighter encounter with Mars, and the outbound leg after Mars naturally guided the comet toward Jupiter's gravity well. To any strategist, this looks like a coordinated survey route, maximizing interaction, sampling multiple planetary environments, and gaining gravitational assists along the way. Layered into this sequence is a curious piece of timing. As Atlas nears perihelion, its closest approach to the Sun, it will slip behind the solar disk from Earth's viewpoint. For weeks, it will disappear into solar glare, masking itself at the most crucial point in its orbit. The fact that the flybys lead directly into this blind spot hasn't gone unnoticed. Each encounter on its own would be statistically notable, but combined in sequence, they create a pattern too specific to dismiss as luck. The growing sense among analysts is that this isn't just a cosmic accident. The data keeps hinting at something deliberate hiding in plain sight. The echoes of past anomalies make that suspicion louder still. Back in 2017, the discovery of 1I/Oumuamua jolted the scientific world. A strange, elongated body cascaded through the solar system, moving like an interstellar visitor. What shocked scientists wasn't just its cigar-like shape or uncertain nature, but the fact that it accelerated on its way out without any sign of typical comet activity. No jets, no trail, no exhaust-like outgassing. Reports called it non-gravitational acceleration, the kind usually linked to venting vapor. But all searches came up blank. This defied natural explanation. For months, theories multiplied: the hydrogen iceberg, a fragment of rock, Strange physics. Then Avi Loeb of Harvard put forward a provocative alternative. He argued that maybe the obvious was the simplest, natural explanations were failing. And this could be artificial, a probe, a device, or debris left by another civilization. His suggestion drew heavy criticism but never completely disappeared. Because the data wouldn't let the enigma go. An unexplainable acceleration, an improbable trajectory, and an absence of measurable emissions left the riddle unsolved. If one anomaly could be tolerated, what does it mean when the pattern reemerges? With 3i Atlas, astronomers now face another interstellar traveler with statistics that defy randomness. Its path isn't just uncommon, it looks eerily like a deliberate survey threading through planetary orbits. Instead of chaos, it shows coordination. To some researchers, including Loeb, this convergence of unlikely outcomes isn't just chance stacking on chance. It suggests something larger, a signal, a pattern hinting that the universe may be more populated, more observant, and more curious than we long assumed. That realization carries enormous weight. The solar system would no longer appear as an isolated sanctuary, but as a crossroad, a place visited, perhaps examined. From outside, every close encounter, every unexplained deviation becomes another reminder that the old certainty of an empty sky may be vanishing. For us, the implications cut deep. The possibility that these objects are more than cosmic debris means Earth is already part of a wider story. If you see randomness in these alignments, or something intentional behind them, your perspective shapes the debate, because as Michio Kaku weighs in on these events, the core issue is shifting, not simply what these visitors are, but what their presence may signify for humanity itself. The raw numbers alone place 3i Atlas in a category that demands entirely new thinking. Michio Kaku studied its measurements, its immense age, extraordinary speed, and near-impossible path across the planetary plane, and raised a question that went far beyond orbital mechanics or chemical anomalies. If this object predates the Sun itself, moves at 58 kilometers per second, and threads the solar system with such uncanny precision, what kind of power or intelligence could have placed it on this journey? His warning wasn't about cinematic destruction, but about scale, the notion that we might be witnessing either the craft or remnants of a civilization operating on levels humans can scarcely imagine. The framework for such speculation comes from the Kardashev scale, introduced in the 1960s by Soviet astronomer Nikolai Kardashev, which classified civilizations by their energy usage. A Type 1 society harvests the full resources of its home planet. A Type 2 civilization controls the energy of its star through constructs like Dyson spheres or stellar engines. A Type 3 civilization manipulates the power of an entire galaxy. Humanity, by Kaku's estimate, sits around 0.7 on that scale, burning fuels, splitting atoms, and collecting a fraction of solar energy, but nowhere near mastery of Earth, much less the Sun. Now imagine an advanced culture, billions of years older, casually deploying materials across interstellar distances, shaping planetary orbits, or altering cometary chemistry with as much ease as we manage satellites. Kaku emphasized that if 3i Atlas truly dates back 7 to 11 billion years, then it formed when the Milky Way itself was still young, when planetary systems arose under different rules. Any civilizations emerging then would have enjoyed a head start of billions of years, enough time to achieve energy dominance on stellar or galactic scales. That timeline hints at abilities so advanced they would appear godlike to us. The stakes here are not limited to astronomy. They extend to perspective itself. If 3i Atlas is natural, then it stands as a time capsule of an age before the Earth formed, a messenger from the ancient galaxy. But if there is even the slightest chance that its trajectory was engineered or its chemistry altered by something with access to stellar-scale technology, then its presence suggests the universe is more than vast. It is inhabited by entities wielding capabilities far beyond our comprehension. Kaku's caution is blunt. Do not underestimate what billions of years of development and mastery of stellar energy can accomplish. In that frame, 3i Atlas is more than a comet. It becomes a monument, a signal of what may dwell beyond the reach of our understanding, waiting to be acknowledged. For millennia, comets have been regarded as omens and messengers. Ancient Chinese astronomers called them broom stars. Their streaming tails seen as signs of upheaval or change. In imperial courts, their sudden appearance could herald dynastic triumphs or collapses. Records from as far back as 240 BC meticulously track their passages through the sky, treating them as warnings or signals, not curiosities. In the Western tradition, comets wove themselves into myth, prophecy, and religion. Some interpretations of the Gospel of Matthew's Star of Bethlehem link it to a comet, possibly even Halley's, guiding travelers on a divine journey. Medieval chronicles brim with accounts of fiery swords and sweeping brooms in the heavens, metaphors for eras ending and eras beginning anew. Even the word comet stems from the Greek for long-haired, evoking their ragged, unpredictable trails across the cosmos. For centuries, humanity gazed upward and saw not just icy fragments, but messages etched into the night. A broom star could presage the downfall of a dynasty. A sudden glow might foretell the birth of a king. That language persists even now. Astronomers continue calling them messengers from the deep, and every discovery carries echoes of the awe embedded in ancient superstitions. Today, with Three-Eye Atlas, the tradition continues. Though telescopes and equations have replaced myth and prophecy, still the questions endure. What does it signify when an object so alien, so ancient, appears in our sky, a relic of chance or signpost pointing to something larger? On July 1st, 2025, astronomers identified Three-Eye Atlas diving into the solar system at 58 kilometers per second. Its staggering 700,000 kilometer wide coma and unprecedented carbon dioxide to water ratio of 8:1 marked it as unlike any known comet. Spectroscopic studies revealed 22 separate nickel emission lines with no iron at all, an unheard-of signature. Its orbit, with under a 0.2% chance of aligning so tightly to the ecliptic, and an even slimmer 0.005% likelihood of achieving multiple planetary flybys, shattered the probabilities for a random interstellar visitor. Even with decades of comet observations and the precedent of Oumuamua's unexplained acceleration, this object breaks through every predefined category. Kaku's alarm remains in force, with chemistry that contradicts all models, orbital paths that defy chance, and an age stretching back billions of years. Three-Eye Atlas may represent more than an interstellar outlier. It may be proof that power, technology, and intent on advanced cosmic scales have already crossed our sky. But its exact purpose, its origins, and whether more like it will follow remain unanswered. As the analysis continues, one thing is undeniable: our perception of the cosmos and of our role within it has changed forever.